Let's take a look at the parts of a radical. The radical sign is actually the black part of this image. The vinculum line is what covers it, sort of the roof of the house. The radicand is what's inside, and the index is normally what we refer to as the square root. The index can be any number. When it's a 2, it's usually not written. Radicals are related to exponents by definition. The radicand is the base, and the index is the denominator of a fractional exponent. Make a factor tree of the radicand. Use the index to determine the size of the groups. Circle the final groups. Each circled group moves outside of the radical. Multiply the values outside of the radical, and then multiply the remaining factors back together. To simplify this problem, we need to simplify each of the terms. So the square root of 18 is the square root of 9 times the square root of 2. The square root of 32 is the square root of 16 times the square root of 2. And the square root of 75 is the square root of 25 times the square root of 3. So the square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5, and then we just bring down the roots. If the roots are identical, then the coefficients in front of those roots can be combined. So if we have 3 square roots of 2 plus 4 square roots of 2, we then have 7 square roots of 2. And this is the square root of 3, so it cannot be combined. In this problem, our first term, 2 root 5, is already simplified. Our second term is not. So I have to separate that into the square root of 4 times the square root of 3, which is 2 root 3. I'll bring down the plus in my first term. Then 27 is the square root of 9 times the square root of 3, which is 3 radical 3. Square root of 5 differs from the square root of 3, but these two terms are both root 3's, so I can combine them. So my final answer, my final solution would be 2 root 5 minus 1 square root 3. The 1 is implied, so I didn't write it. In the next example, we need to rationalize the denominator. In your later mathematics work, you will rationalize numerators, but right now, we don't want a square root in the denominator. Just like you don't have fractions or decimals in fractions, you don't want a square root in the denominator. I do want to note that this is the same thing as writing the square root of 5 over the square root of 3. That said, if I take the square root of 3 and multiply it by the square root of 3, then I get the square root of 9 inside parts times inside parts. Square root of 9 is simply 3. But I can't take a fraction and only multiply the denominator by something. What I want to do is multiply it by a value of 1. So root 3 over root 3 would simplify to 1. When I do that, inside parts times inside parts, radicands times radicands, I get root 15 over 3. Now I've rationalized that denominator. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.